New insights from Phylogenomics of Opuntia.
So, hello everyone. It's a pleasure to be here. I'm very happy, but I'm really nervous because it might be my first talk in English, so I apologize for any unexpected. So, I am Matias Kohler. I'm from the University of Rio Grande do Sul, Brazil, and I visit the research of Florida Museum of Natural History. And today I'm going to present to you part of the work that have been done, deep into critical history from new sites from the Phylogenomics of Opuntia since last. So cacti are one of the most charismatic group of plants of the world, and probably most of you must have one of your house. I don't know, maybe growing in a pot, stamping a T-shirt in a coffee mug, and nowadays they are in every place, and we are in Tucson. So, and probably one of the features that make cacti so intriguing is the highly diverse life form that you can see growing in nature. You can see like columnar cacti, barrel cacti, epiphytic cacti, creeping to erected shrub, and all these highly diverse life forms is also adaptations to survive in arid regions, arid and dry regions across all the Americas. So we have cacti as conspicuous elements of the arid regions from North, Central, and South America. And also this highly diverse life form is represented in a diverse family with around 1,500 species. And some of these species has a narrowly endemic distribution. So cacti are one of the 50 most endangered group of any taxonomic group in the world, with around 30% of the species under some kind of threat. And the family is basically composed by three major clades that we recognize as subfamilies: the Cactoideae as the most diverse subfamily, Myoenioideae as a monogeneric subfamily and an iconic group from the South American deserts, and the Opuntioideae subfamily that we'll be talking more later. And the traditional Periskioideae subfamily have been recovered as a basal grade in the base of the tree of the cacti, so it's not a monophyletic subfamily. So Opuntia is the main genus of the Opuntioideae subfamily. It's the most widespread group across all the Americas. So we have members from the South Argentina to the south of the Canada. It's the second highly diverse, species-rich, diverse genus of the family after Mammillaria, with around 200 species. And it's widely spread and growing to the fruit production from the prickliers, and also for the nopales, the stems that are used for cook, and also to grow the scale insect to produce the carbon cochineal pigment. So from an evolutionary perspective, we have a previous study from the genus that revealed a first clade delineation of the genus with five North American clades and 2 South American clades in a positive geographical region, and also in the study, Majority and collaborators revealed that polyploidy and hybridization has a really important driver to the diversification of the species level. So although in this previous study some important relationships were lacking support that we highlight in this red arrow here, and also with missing like a comprehensive sample including diploids from North America, South American clade, the Macrobrided clade, and even the alt groups. So our goal is basically to reaccess the evolutionary history of the Opuntia, genus Cactaceae, using a phylogenomic framework, testing the divergence time estimation and the biogeographic history, and also infer ancestral states reconstruction for the hummingbird population in Dioece, since that we have like Consolea as a sister to the rest of the Opuntia with these 2 features. So we were interested to test if this is ancestral state in the Opuntia. So to do this, we sample all the diploid stacks in the Opuntia, almost all, you can see. We pull out the polyploids because they are not evolving in a cladogenous way. So we were interested in clade delineation. We use representative members from the Opuntia, Tetrocacti tribes, subfamily Cactoideae, members of the Periskioideae and Cactaceae as alt groups. We made genome scheming using high-sec Illumina, 10 Illumina in rapid genomes, and with this data we We made a genome assemble to capture a chloroplast genome that we use to reference map our raw reads. We made phylogenetic inference using RAXML, maximum likelihood with RAXML, and Bayesian inference with BEAST. We also test the recent proposed to the multi-species coefficient to test incongruence between gene trees from our plastid and our species tree using Astro. So the divergence time estimation was made in BEAST, as Abreu said. And the historical biogeographic analysis, we used the biogeographers in our package. And the diversification rates was made using two Bayesian approaches like BAM and RevBase. And the stochastic reconstruction was using a maximum likelihood approach with MSQuit. So our first, we pursued different approach to test the chloroplast from Opuntia. And our genius de novo assemble resulted in one big plastid counting with 128,000 of pair base, and that we confirmed as plastin to the portulaca of the restoplastum and annotating with this, and also with dogma. We recovered our RBCL TRNV inversion that actually is a synapomorphy of Cactaceae. We recovered a putative loss of one of the inverted repeats, two putative inversions in the large single copy that here is highlighted, and we recovered the presence of all the ND8 gene suite in the chloroplast of the Opuntia Kimilo. We also recovered three putative pseudogenes, ACCD, YCF1, and YCF2, that we have been talking later. And all this kind of uncommon or rare arrangement that we can see in this plasm is not so weird when we talk about the cacti plasms, because the first plasm that we have in the literature is from the saguaro cactus, where the Sanderson and collaborators reveal exceptional reduction of the plasm of the saguaro cacti with a complete loss of one of the inverted repeats, and also the loss of all the NDHJ gene suite. And interested to see with that how this pattern of the three pseudogenes, ACCD, YCF1, and YCF2, is represented across the coverage of the plasm across the different taxa. We can see that here the ICF2 has a different pattern of coverage. This blue line represents the coverage of the raw reads plasted to our reference plastum, and I will talk about this soon. So from our chloroplast assemble, we got like 122 pair base alignment that we will strip the three pseudogenes since they are very hard to align, and doesn't make sense actually the alignment in this part of the region. This is the RAXML tree, the most likely tree from the RAXML, using GTR down as model of evolution and 1,000 of bootstrap to know the branch estimation. So we recovered basically a pretty well supported backbone to the even to the out group, our in group of interest, with the 100 of support for almost all of the clades. So for North American clade, we have like 6 clades: Macrocentra, Pumitusa, Cetispina, Sheriani, Basilaris, and Opalea, and 2 South American clades, Elata and Machybraille. What really calls attention when we look to the phylogram is the really short branch of the Opuntia tribe when we compare to the Tephrocaci, Cylindropunti, and especially with Cactoid plastum. That is something that deserves further studies. So besides this higher support for the majority of the clades from the previous studies, we also recovered a different topology for the Machybraille clade, and with total support that was not previously recovered as sister of the South American and North American clades. Also the Cetispina clade with Opuntia Cetispina, Opuntia Gosseliana, and Opuntia Santa Rita as a new clade that was not previously recovered. They were all in the Macrocentra clade. And the Salmon Opuntia nested in the Tunisia and Michele Opuntia. This is part of the Opuntia sensulata. So, given this lower support for the position of the Cetispina and the relationship between Nopalea and Basilaris clade, we pursued the multi-species quality to test the difference, the congruence and incongruence between the plastic genes. So we run the multi-species quality theory using 105 gene trees from the plastic, and actually we recovered a pretty low value for the normal Corti score that revealed to us a high discordance between the gene in the plastic. So although we didn't have good support for the clades, and this is a slightly different topology, this could be related with incomplete linear circuit in the group, hybridization, or even the lack of the phylogenetic signal in the genes of the chloroplast. And although we still not have good morphological characters to synapomorphic characters for each of the clades, it's pretty interesting to look how the pattern of the coverage in YCF2 region is like a putative molecular synapomorphic for the clades. So we can see in the South American clade a high coverage in YCF2. We have like a full YCF2 in the Lata clade. A small a small loss of the YCF2 in the Macroidae. And for the Cactaceae, Sherian, and Basilaris, and Nopalea clade, a completely low coverage of YCF2 region. And in the Microcentral and in the Fusa, in the Microcentral and Fusa clade, we have like just a peak of coverage of YCF2. When we look to the chronogram and time diverse estimation, we can see that Opuntia has a stem age of around 7 million years ago. And so it's a really recent group, the divergence group. And this is pretty interesting when we look to the speciation rate to the time. So in a range of 5 million years ago, basically we have a duplication of the speciation rate. So that we can test later why this is related. To the biogeographical history, we recovered the Central South American region as an ancestral area estimated for the ancestral of the Opuntia, and with a subsequent long dispersal events to the North American deserts. And then from the North American desert, subsequent dispersals to the east coast plain of the United States, Central America, and Caribbean region. And yeah. So when we look to the ancestral state reconstruction, we have the Consolea as a hummingbird pollination and also a dioecious group. And we test if this could be an ancestral state for the group. So actually it's most unlikely that this is an ancestral state. So actually the hummingbird pollination and the dioecious have evolved at different times in the group in Opuntia sensu-street. We have Opuntia cetispina with a hummingbird pollination in dioecious. We have hummingbird pollination in Nopalea clade. We have hummingbird pollination in Chimilo and Microidae quitensis. And so it's not synapomorphic. So concluding, the plaston is really phylogenetically informative, but the content and the structure deserve further studies that can be really different across the taxa. We recover 8 measured diploid clades in Opuntia sensu-street with 6 North American and 2 South American clades. We reveal incongruence between the blastidial genes that could be related with incompletely inserted or, okay. Early and rapid radiation with an increase in speciation rate in a short period of time. A long dispersal event from the Central South America and to North American deserts, and 6 pollination shifts to the hummingbird pollination. So the perspectives, we are not focusing on the South American clades. We have further chromosomes counts to do, clade delineation, species delimitation, probably to deal with nuclear markers to the species delimitation, and to test the hybridization and putative origins. So I wish to thank to all these institutions that have funding supporting these studies, also these guys that can help in some part of the work, and thank you for all.